frequency polygons, and Ogives. Ogives are again just categorical, frequency distribution graphs, but we'll cumulative frequency distribution graphs, but we'll talk about that here in this second. So in objective 2, we want to represent data in frequency distributions graphically using histograms, frequency polygons, and Ogives. So when data are organized into a frequency distribution, the summary can be presented in graphical form. The most commonly used are as follows. We have histograms, which you know as a graph that display data using continuous vertical bars, also known as bar graphs. Unless the class frequency is 0 of height representing the frequency of the class. So if it represents 0, you just won't have a vertical bar. It'll be the absence of one, which means there's an absence of data there. Then you have a frequency polygon. This is the graph that displays data using lines that connect points plotted at heights representing class frequencies at the midpoints of the classes. This is called a line graph. To kind of give you an example, it'd be like this if you had an histogram, but then we just connect it with dots. Where this one, these dots that you would typically have, we just make them vertical bars. This is completely random data, but that's what that would be. A cumulative frequency graph, or also known as a Ogive, is graphs that represent the cumulative frequencies for the class in that frequency. So it's still going to be a line graph, but now the lines are going to be getting more each time. So it'll be like this. So it's still a line graph, but it's cumulative going up to that 100% mark. All right, so I'm not going to make you do all that data again from 2.1. But here is the data that's nicely done all for us, nice and clean, just in case you don't have the best of handwriting. But again, what we're going to do here is we're going to construct a histogram, a frequency polygon, and an Ogive from the frequency distribution representing the salaries of a sample of 30 colleges and university coaches in the United States from the previous example. So in example 4, we're going to first construct a histogram, right? So the first thing you want to do is draw the axis, right? You should have an x-axis and a y-axis. So the x-axis is the horizontal axis and the y-axis is the vertical axis. Step 2, you must label these axes. The x-axis is the horizontal axis labeled with the lower class boundaries or categorical, right? So you could have your A, B, O, and double AB. Or you have your classes like, 140 to 229, 230 to 319, and so on and so on. But the y-axis or the vertical axis will be labeled with values of frequency. So that would be 1, 2, 3, 4. How many times did we get a number in that class? Step 3, using the frequencies as heights, we're just going to draw the vertical bars for each class, displaying our data. So this is already kind of done for you to save yourself some time, but we're going to add a couple things to it. All right, so here we go. So you have a title for it. You have your x-axis labeled with, they went with the mid-range, which is completely okay. I like actually typing or writing out the lower and upper bound, but this is a typical thing to do as well. And then they went by frequency, and since they had one at 11 and some at 1, they decided to go by 2. Is completely okay too. But the one thing I noticed on this one is they're missing is we don't have this label. So this needs to be class boundaries in salaries. And this right here would be your frequency. Right? And just adding those labels there makes a complete table. All right. So there's an example there, and we will eventually make a histogram. In example 5, we're going to construct a frequency polygon. All right, so in this one, you find the midpoint of each class, which we did already in the frequency chart. Step 2, we're going to label the X and Y axis. The X axis is going to be labeled with class midpoints, as you can see above. The y-axis is going to be, I don't know why there's a T there, is labeled with class frequency as above. And then step 3, at each class midpoint, we're going to plot points at the height representing the frequency for each class. All right. So as you can see there, I had the 94.5, so I had to start at the midpoint of the class before it, so it can start at 0. And then you want to then shoot up to 11. And then you can see that the next one's at 5. We plateaued at 4 for a couple of classes, went down to 0, plateaued to 1 for a couple of classes. And then you want to do the midpoint of the class past yours. So again, it comes back down to 0. So this would be a frequency distribution graph right here, also known as your frequency polygon. All right, so with that, looking at example 6, very much the exact same thing, but to do a ogive, this is going to be finding the cumulative. If I can get it all, no, I'm not going to be able to get step 3. All right, so this would be the cumulative frequency of each class. So again, pulling the data from previously, this would have been 11, 16, 20, 24, 28, 28 because there was none in that one, 29, and then 30. Step 2, just like in all of them, you will then label the X and Y axis. The X axis is labeled with class midpoint to make it a little bit easier to read. The y-axis is then labeled with a scale appropriate for the cumulative frequency. Again, beforehand on the frequency polygon, 11 was the biggest, 0 being the smallest, we went by 2s. But here, my smallest is 11, I go all the way to 30. I might want to go by 5s or even potentially 10s. Well, 10 will be only 3. I'd probably want to go by 5s or even maybe 6 if you wanted to. Mm-hmm. That last step there, let me get to that step 3. At each upper class boundary, we're going to plot the cumulative frequency point. And then in step 4, we're just going to start with the first upper class boundary and connect adjacent. So with frequency polygons, you got to start with the class below your lowest and above your highest so that each end starts at 0. But cumulative, we can start from the get-go and just go up. So you can see we started here at 11. There's my little thing. We started here at 11 and then just progressively went up. So it does look like it's a straight line, but there are some upticks here. The average was a 4 each time as well. All right, so that would be an example of an ogive. So a relative frequency graph uses the relative frequencies or appropriate scale instead of frequencies. The graph looks the same, only the scale of the y-axis is different, and we steadily have a positive or a constant growth. We don't ever go down with a ogive. All right, so using histograms to describe the shape of distributions, although distributions are not often perfectly shaped, identify an overall pattern. So we do these frequency charts so that we can see the data graphically, and then starts kind of making a little more sense. So some graphs that I'm going to expect you to see and then know what it's called. All right, this is what we call bell shaped because it looks like a bell. Typically, your mean is right here and it's distributive evenly on both sides. A uniform bar graph, there's no high values. It's pretty much the same, give or take, all the way across. We have what we call a J-shaped. And then on this J-shaped, because this is going to kind of be I mean, really and truly, that's what it is. So a J shaped, it just goes from it's like stairs all the way up, and kind of makes a J in a sense. A reverse J would be if you're going down the stairs. So a J shaped going up stairs, reverse J shaped going down the stairs. And again, what they're doing to make a J is they're kind of like, that's a J right there. Don't make it look like you're drawing it this way. And then a reverse J would be like that, right? Or like that, like a backwards J. All right, and then we have the most used one, which is right skewed and left skewed. To be right skewed, most of the data is on the left, but then there's data being pulled from the right. So what it is here's where the average should be, but then the data on the right skews the data to the right. So maybe the average is over here since these are so large of numbers. A left skewed, completely opposite of that. A left skewed, all the data is on the right, but there's some data on the left that's bringing the data back down. So the average should be up here, but because of these, what we're going to call outliers, is bringing the data to be less than what it is. A binomial graph is just a thing with two high points. So it's bimodal, right? Bimodal because it has two high points. U-shaped data literally just makes a U inside the graph. So you have, again, bell shape, it's evenly distributed. Uniform, it's pretty much the same across. J shape makes a J. Reverse J makes the opposite of a J. Then you have right skewed, all the data is on the left, but you have data on the right that's pulling it. Left skewed, all the data is on the right, but you have data pulling it to the left. Bimodal, two high points. U-shaped, it has basically two high points on the far left and far right, and the data is kind of down on the bottom. Alrighty. So that's pretty much all that I have for 2.2, and we'll stop this video here, and then I'll do another video for the rest of chapter 2 in a later video. If you need any more help or more examples for your homework as you're studying or working out the problems, reach out to me by email. Let me know. I don't mind doing more videos or working out some more problems. Other than that, see you in the next video.